You are going to like this one. Getting away from boring equations and starting to work with more interesting inequalities. We're going to graph linear inequalities and starting to really get into some nice Algebra 2 here. Some systems of inequalities. This will set us up so that in the next section we can do a very useful kind of activity called linear programming. You'll see how practical it is in a moment. First, a brief review. Graph the points on a line that satisfy the inequality of 3 is less than x. So our boundary is at 3. If we mark this as 0, 1, 2, then this is our 3. We're saying that 3 is less than x, or another way we could say it, a more conventional way to say it would be x is greater than 3. And once we put it that way, it seems a lot clearer, doesn't it? Does 3, 1, that's my x-coordinate, my y-coordinate, satisfy this equality? Notice this equality, we've got an equal sign. So 2 times x, which is 3, gives us 6. 3 times y, which is 1, I'm going to add that, which is 3. That does not equal 5. So no, this point does not lie on this line. Shade the area underneath the line x plus y equals 2. Shade above the x-axis, so we've got that quadrant here, haven't we, in the right of the y-axis. This is quadrant 1. I'm going to transform this into the slope-intercept form because I already like it for graphing, but it is especially useful when we do inequalities, so we'll keep on practicing it. I'm going to subtract x from both sides. And now what happens? My y-intercept becomes very apparent. I know it's at 2, so here it is, right here. It's my y-intercept right there. And my slope is a -1. So -1 means I go down 1 over 1. That would be a -1. And go down 1 over 1 and just keep on doing that. So I've got a line right here. And I have another boundary right here formed by my y-axis and another boundary right here formed by my x-axis. So when I fill that in, which I would like to do now, it's just this little triangle right here, which is a solution. Well, it's the space within these boundaries. We're going to talk about solutions of inequalities in just a moment. Before we do, we want to talk a little bit more about inequalities and how we graph them. This actually is another depiction of what we just did. Shade the area underneath this line, and remember I rewrote that line as y equals -x plus 2. Oh, that doesn't work too well, does it? 2x plus 2. Here's that boundary line, and the solution, when we express it as an inequality, less than, anytime something's less than, it's going to be underneath. That's directly down. Do not get in the habit of thinking right and left. There's only one time when we actually use that thinking. We'll talk about it in a minute. When you're talking about y being less than, you're always looking down. If this had been greater than, we'd be going above the boundary line. Systems of inequalities, I've got some here, and you can see what's happening. I transform this into slope-intercept form for my boundary line, and then I look at everything less than. I'm using a solid line because I include, see how it's equal? It's equal to this boundary line and everything below it. So when you have less than, you're going to be looking below it. When you have greater than, as we do here, you're looking above. The only difference with this purple one and the blue one is that we're using a dotted line. And I'm sure you know why that is. Yes, we don't have an equal sign here. So we're going to be going below, but we're going to show our boundary as a dotted line. On this one, we're going to use the dotted line, but y is greater than, so we shade the area above that boundary line. Now we're going to try another one ourselves. Let's see. When I transform this into slope-intercept form, this is what it looks like. And I'm going to grab a line that I can use. It'd be a solid line, right? It should be solid because this includes equals. And I want to have a slope of up 3 over 2. So I haven't got the right, whoops, I need to change, needs to be a positive slope, up 3 over 2, I know it's fairly steep, let's see if I can work this out. Up 3 over 2, actually worked out pretty well, up 3 over, well, maybe a little too steep. Oh, great, that's not what I wanted, yeah. Let's see how that one looks. Okay, so up 3 over 2, up 3 over 2, up 3 over 2, not too bad. I might be able to improve it a little bit. Up 3 over 2, if I move it, I don't know why that does that. You know how it is when you have a tool and it's not quite the right thing, but it's the only thing you have? That's what I've got here. So I've got the right slope on this, but I do not have the right intercept, do I? I need to change that. So let me mark it. It should be intercepting at -3, which would be right here. Okay. So let's move it to where it's supposed to be. There. Now, I have my boundary line. And where am I supposed to be shading? Underneath it. So I'm going to shade below this boundary line. All right, we'll do another one. This green one. Transform it into a linear equation. Has the same slope. Well, that's good. I actually grabbed this one. I'm going to use exactly the same slope, so that works out well. What is different? Actually, the only difference is my intercept, isn't it? So mark that at +3 right there. Move my line, which is at the right slope right now, into the correct position. And how am I going to do my shading? Above or below this line? I'm going to be below it right here. All right, so we've done a whole mess of inequalities. Now we want to put them together into the system that I promised. Told you it would get more exciting, and here it is. We're going to do a couple inequalities on the same graph. They're working together as a single system. Their solution will be all those points that they share in common. So let's look at this boundary line. I want a solid line, and it needs to have a negative slope, which it already does, but it has to be precise, doesn't it? Down 2 over 3, which it is not right now. Down 2 over 3. How close am I getting? Down 2 over 3. Not enough. All right. Down 2 over 3. That looks pretty good. Oh, now I got too shallow a slope on that. Down 2 over 3, down 2 over 3, down 2 over 3. Oh, this one looks just fine. All right, so down 2 over 3, but I need to anchor it where the intercept is. Oh, the intercept is at +2, so let's mark it right there. I'll move my line into that location, and just let me mark it with little tiny arrows. We're going to be going below, right? So I'm just going to put a couple little tiny arrows to remind us that our solution is everything to that side of that line. Now we're going to do the green line and see if we can put that into the, whoop. That's not what I want to do. I want this. And I do want a solid line here, and I've got a very steep negative slope, don't I? See if I can get this to work just right here. I'm not sure I've got it just right. So down 4 over 1 is what we're going for, isn't it? Down 4 over 1. That looks pretty good. But we have to anchor it properly. It needs to be anchored at +4, which would be right there. All right. So I have both my boundary lines, and this one is less than x2. Remember, we're going down. We're not going left, we're going down. So where do they share solutions in common? Right here. All of this they share in common. There is a point of intersection of these boundary lines. It's right here. Right there. That's the point of intersection. There are intercepts of these boundary lines with the axes. There's an intercept right here. This is the next intercept. Here's another one. We've got one here, which we've already marked, and here, which we've already marked. But probably the critical one is this, where the boundary lines meet, because this is a vertex of your solution space. Those are going to be important, not in today's lesson, but in the next one. This is just a representation of what we just did. Let me mark the common area here with yellow. Here are the steps we go through when we are working with a system of inequalities. For each inequality, we establish the equation of the boundary. That is a line. We know that an inequality is not a line, but it does have a boundary which is expressed as a line. Then we sketch the boundary line. Then we shade the solution area. If you have established this equation in terms of y equals mx plus b, and you have expressed your inequality, whatever it is, in this same form, then when you shade the solution space, you will know if it's y less than or y less than or equal to that you're going to shade under. If it's y greater than or equal to, or simply y greater than, you're going to shade above the line. You repeat this for each inequality statement, and you establish the solution space as the area that is common to all. Now in this case we had two inequalities. We're going to come across one right now where we have three. Oh, I'm sorry, four. Mathematician who can't count. All right. And I think I will try drawing this. We've got an anchor here for our boundary line. What did we say we were going to do? Establish the equation of the boundary, and I like to do that in y equals mx plus b form. Sketch it. All right, so we're going to sketch that boundary. We've got it in the form I like, and we've got a negative slope. We're going to go down 2 over 3. We're going to go down 2 over 3 and down 2 over 3. So we're establishing our boundary line right here. And why don't I draw that to the best of my hand-drawn ability. So there's my boundary line. And which side of it are we saying our solution lies on? This side. So draw your little arrows to remind yourself of that. Now we'll do the next one. The next one is anchored at an intercept of 1. Has a very steep negative slope down, well, very shallow I should say, down 1 over 5. Down 1 over 5. So this is a very shallow one. Try to draw it straight for you. So that's the other boundary line. And which side of this are we interested in? Yes, this one is also less than. Less than. Then we have x greater than 0. So what we're talking about here is right here. We're going to be, basically what these say is that we're going to be in quadrant 1. And we're going to have a y which is greater than 0. So let's mark the space that we're interested in, which is only in the first quadrant, right here. Maybe if I just draw dots. There. So that's our solution space right there. Where are our vertices for this solution space? Well, clearly we've got one right here at the origin, and then we've got one at our y-axis and another at our x-axis. So far I've got 3 vertices, and there's one I haven't touched yet, which is right here where these 2 boundary lines come together. So I do have 4 vertices of my solution space, which I have highlighted in yellow. Well, we got through that pretty well. We're done with all the basics associated with inequalities, systems of inequalities.